Here's a little introductory video, or actually kind of, let's say, review video on how inequalities work on the number line. This should be old stuff, but it's been a while, so let's start with the basics. These are the inequalities. We've got greater than, and less than, and greater than or equal to, and less than or equal to. And just like equations, we can have true inequalities. 5 is less than 10. That's true. We can have inequalities that are not true. 4 is less than 4. That's not true. 4 is equal to 4. So that one is true because it only has to satisfy one part of that inequality. So that one's true. We can also see compound inequalities. So we need to know how to read that. -2 is less than 0 is less than 2. That one's a true one. We can also say that 0 is between -2 and 2. And we'll usually write those in the same order the numbers would appear on the number line. Smallest on the left, biggest on the right. So let's look at a couple equations, some equals problems on the number line, or solutions graphed on the number line. If I have x is equal to 3, 3 is my only answer, so I put a dot, a solid dot, or a point on 3. If I'm going to graph x is -1 or 4, I'm going to have a dot on both of those, or a point on both of those. So I have 2 dots. That's for equals. We're going to shade in just that dot because that point is my only solution, or those 2 points are my only solution. Now when we have inequalities, the ones with the equals attached, greater than or equal to or less than or equal to, we're going to have a big solid dot. We're going to have a point because wherever that number is included in our solution, but then we're also going to shade in one direction or another, either left or right. On the greater than and the less than ones, we're going to have an open dot because wherever we're putting that dot, that starting point, that number's not part of our solution. If we just tried to do an arrow up to it but not have some kind of a dot, it'd be hard to tell where it started and where it stopped and stuff. So we'll do the dot and then we'll shade. So let's look at a couple. We've got x is greater than or equal to 2. So on the number line, we're going to put a solid dot on 2 because 2 is part of our answer, and then we're going to shade to the right. The reason we shade to the right is we want the numbers that will make that statement true. So I could substitute the values to the right because those are the larger values. 3 is greater than or equal to 2. That's a true statement. 4 is greater than or equal to 2. That's a true statement. I could plug in any number greater than 2 and it's going to be true. That's why we shade with the arrow to show it goes on forever. X is greater than 2. The difference is this time on 2 we're going to have an open dot because 2 is not part of our answer. And we're going to do our shading. Right? 2 is not greater than 2, so that's why we have the open dot. Here we've got another inequality. X is less than 0. So this time we want to include only those numbers that are smaller than 0. So we want all those negative numbers. If we inserted any negative number, that would be a true statement. That's why we shaded that direction. I want to talk about the ones like this because a lot of people think we shade whatever direction the arrow points or the inequality points, and that's not true. This one says 4 is less than x. So what we want to do is we want to think about what numbers can we substitute in there to make that a true statement. 4 is less than what numbers? Well, 4 is less than 5 and 8 and 200, right? 4 is less than those numbers. So it might be easier when we're graphing it to rewrite it first. X is greater than 4. Those two statements, those are equivalent statements. So if you can think about 4 is less than x, okay, great, leave it. If it makes more sense to you to say x is greater than 4, then rewrite that. Notice everything flipped around. We wrote the x on the left, it used to be on the right. The symbol flipped around and then the number moved spots. So this graph would represent both of those statements. Open dot on 4 and all those bigger numbers. 4 is less than 6, that's true. 6 is greater than 4. That's true. So that's why we shaded that direction. Right? The direction of the arrow on a number line does not always match the direction of the inequality.